Welcome back to part 2 of chapter 5, module 5, factors and multiples. We're going to start off with example number 2, find the greatest common factor by using a factor tree. And they like factor trees, apparently. I like upside down division. I'm going to show you both. I think you're going to like my way better. It says use factor trees to find the greatest common factor of 52 and 78. And it says think about it. How will you set up the factor tree for each number? Well, if it's me doing it, I won't. I'm going to use upside down division. Now this should bring some flashbacks for you. 52's factor tree said 2 times, that's going to be 26. And from there, 26 was 2 times what? 13. So the factors were 2 times 2 times 13. And then over here, 78, that became 2 times, let's see, 35, 36, 37, hold on, 39. I believe is going to be the number to go there. And then, of course, 39, that is going to become 3 times 13. Check it, and that would be the factor tree. Very similar to what I'm sure you used when you were in elementary school and in 6th grade. But we are in 6th grade. I totally forgot this was a 6th grade lesson. We are going to take this even further, though. Now we're going to move through the slides and determine the greatest common factor. We're going to look at the bottom row of each factor tree and see the prime factors. You got a 2, a 2, and a 13. Here you have a 2, a 3, and a 13. So the prime factors they have in common are going to be 2 and a 13. 1, 2, and 1, 13 that they share. From there, moving on to the next slide, it says, what if we were to take and use some different factors for these? So here they said 52 would this time be 13 times 4, and 4 is, of course, going to be 2 times 2. And you can see we get the same factors for 52, 13, 2, and 2. Likewise, 78 could be listed as let's see here, 13 times 6, and 6 is of course going to be 2 times 3, and what do you know, you have the same exact factors there as well of 13, 2, and 3. What the point of that is it doesn't matter how you go about factoring it, in the end you're going to have the same exact factors as you would any other way you chose to go about it. Now it's going to be your turn to use factor trees, and you factor 24 and 60 and find out what the greatest common factor is going to be between those two numbers. So let's do this the way they did it, and then we're going to do it the way I would do it. First off, doing a factor tree for 24, I would say, well, 24 is going to be 2 times 12. 2's done, and then I'm going to say 12 is going to be 3 times 4. All right. 3's done, and then 4 is going to be 2 times 2, so that would be 2 times 3 times 2 times 2 times 2. And then over here, for the 60, we're going to end up getting the, now I'm going to break this down as 3 times 20. 20 is going to be a 4 times 5, and of course 4 is going to be a 2 times 2. So what do you have here? You have 2 times 2 times 3 times 5. When you go to find out what they have in common, they share 2 2's and they share 1 3. So the greatest common factor, something they didn't really show you in that last example, which they should have, is you take out what they share. 2 times 2 times 3. 2 times 2 is 4. 4 times 3, that's going to be 12, making 12 be your greatest common factor. Coming back over to their problem, we're going to type in the 12, we're going to check it, and it checks. That shows the problem of the factoring using their method, which is kind of big and kind of spread out. I'm going to show you using my method, which I call upside down division. And I'm going to write each problem with a division house, only my division house is upside down. From here, I'm looking for the smallest prime numbers that will divide into each of those. So 24, the smallest prime number to divide into 24 is 2, and 2 goes into 24 12 times. See what I mean by upside down division? I'm going down. Then I'm going to put I said 12 is going to be a composite number. So I'm going to say, well, what's the smallest prime number is going to go into 12? It's 2, and it goes into it 6 times. And then I say, well, 6 is a composite number as well. 2 goes into it 3 times, and now I have 2 times 2 times 2 times 3. Isn't this a lot neater and more compact than that? Let's look at 60. 2 goes into 60 30 times. 2 goes into 30 15 times. And 3 goes into 15 5 times. And you stop when you get to prime numbers. If you have all prime numbers outside your houses, you know you're done. That one therefore will be 2 times 2 times 3 times 5. And just like the last one, what did they share? They shared 2 2's, and they shared, whoops, that's not a 3, 1 3 each. So that gave you the same 2 times 2 times 3, also known as 12, for your greatest common factor. It's a different way to do it, but which one of these is neater, more concise, and really easier to see? It's really the one on the right. That's what I want you to be using in your homework tonight. Now your textbook is wanting to jump straight into least common multiples, and I don't think we're ready for that. So let's take and let's find another set of greatest common factors. I want you to do the greatest common factors of, let's do 24 and 32. Find the greatest common factor of those using prime factorization to do it, and the prime factorization I want you to use is upside down division. Pause the video and do that now. Okay, I set it up. I got my upside down division houses going. I'm going to say the smallest prime number is going to go into 24. That's going to be 2, and 2 goes into 24 12 times. 12 is a composite number, meaning it's divisible by more than 1 in itself. So I'm going to put a house around it. I'm going to say the smallest prime number, a prime number that's divisible only by 1 in itself, that'll divide into that, is 2 again. 2 goes into 12 6 times. 6 is, yep, it's composite. So I'm going to put a house around it. Smallest prime number is going to go into 6. That's 2. 2 goes into 6 3 times, and 3 is a prime number. So now we're done factoring that. Is 2 times 2 times 2 times 3. For the 32, smallest prime number is going to go into 32 is going to be 2. It's going to go into that 16 times. Put a house around it because 16 is a composite number. Smallest prime number that's going to go into 16, that's 2. It's going to go into 16 8 times. 8's composite. Smallest prime number is going to go into 8, that's 2, and it's going to go into it 4 times. 4's composite. Smallest prime number is going to go into 4, that's 2 as well, and 2 is going to go into 4 2 times, and now we have the factors of that one is 2 times 2 times 2 times 2 times 2. So let's start picking out what they share. I got a 2 here, I've got a 2 here, and I've got a 2 here. These are what they share. It's what they have in common. So I can come down and say my greatest common factor is 2 times 2 times 2, also known as 8, and 8 is going to be the largest number that divides into both 24 and 32. Let me emphasize that. This 2 right here is shared right there. This 2 right here is shared right here. And nice rainbow color. This 2 right here, it's really a horrible rainbow color, is shared right there. Okay? Those are shared 2's creating your greatest common factors. Now we're going to take a look at least common multiples. A least common multiple is going to be the least number that is a multiple of 2 whole numbers. So let's take a look and see what they're talking about here. Go on to our next slide. And it tells us that a multiple of a number is the product of that number and any whole number. And what strategies could you use to find multiples of 2 whole numbers to share? Well, let's go back to the Wayback Machine and look at what they did in elementary school. So in elementary school, they made you list all the multiples, and we're going to have a real quick computer simulation of the multiples of 3 and the multiples of 4. Multiples of 3 will be orange, multiples of 4 will be blue, and the ones that they have in common, well, you get it, War Eagle, orange and blue together. So you can see the multiples of 3, 3, 6, 9, 12, 15, 18, 21, 24, and so on. Meanwhile, the multiples of 4 were 4, 8, 12, 16, 20, 24, and so on. And then when you wanted to know what is the least one that they have in common, well, that's going to be the 12 right here. It's the smallest number, the smallest multiple of both 3 and 4 that they share. Now, 24 is also a common multiple, so is 36. But neither of those are going to be least common multiples. Only the 12 is going to be your least common multiple. The textbook tells us that the common multiples of a pair of numbers are multiples of both numbers. The smallest of these is going to be your least common multiple. And what is the least common multiple? Well, we already talked about it. That's going to be the 12. The 12 is the least common multiple. It checks. Easy math. Now they want us to find the least common multiple of 3 and 5, and using the sketch pad, that means I need to take that number, change it to 5, and then from there, go ahead and show the multiples, and you can see, oh, there it is right there, 15. That's going to be the least multiple that both 3 and 5 have in common, making 15 be our least common multiple. Really easy math here. So in the two that we did, the least common multiple of 3 and 4 was 12, and 12 is 3 times 4. The least common multiple of 3 and 5 was 15, and 3 times 5 is 15. So, does that mean that the least common multiple of every number is going to be the product of those two numbers? No, it's not. Let's talk about, I don't know, 4 and 8. 4 times 8 is 32. Is 32 the least common multiple of 4 and 8? No, it's not. 8 is the least common multiple of 4 and 8. 8 times 1 and 4 times 2, both of them equal to 8. Now the textbook suggested us doing this with 2 and 4 instead of the 4 and 8 like I suggested. And you can see when it starts showing all the multiples here, to show you your least common multiple of 2 and 4, that's going to be the 4. But 2 times 4, that was going to be the 8. 8 is a common multiple, but it's not the least common multiple. The least common multiple is 4. Now everything we've done so far has been using their fancy technology. Let's go back old school to how you did it when you were a wee little brat in elementary school. Find the least common multiples of 4 and 6. Go ahead and do that now, and then we will come back and look and see how I did it. So how did you do it? Let me show you what I think you should have done or would have done back in your elementary school days. This is what we did back when I was in elementary school. I would have started with a 4, and then I would have said, oh, I don't like rainbows. I would have said it's going to be 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is going to be 12, 4 times 4 is going to be 16, 4 times 5, well, that's going to be 20. And that's a good start for 4. 6 times 1 is 6, 6 times 2 is, hey, right there, ding, ding, ding. That would be the least common multiple of 4 and 6. That look familiar? I bet it does. Alright, enough of the exploring. Now it's time to start getting down to some business. The least non-zero number that is a multiple of 2 or more numbers is the least common multiple, or LCM of the numbers. Vocab term, ding, 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 ding. You can find it 2 ways. You can find it by listing numbers, or they say you can find it using a number line. There's another way I like to find it, using common factors, but apparently that's not what you're going to learn today. Now that's all the more we're going to be doing for part 2 of this video. When we come back to part 3, we're going to watch the textbook video on finding least common multiples, and then we're going to dig in and learn more about how to find them on our own. See you in part 3.